Greetings, everyone. It is so great to have you with us today. We have a fantastic mix of press, friends, scientists, strategic advisors, and partners on this call today. Welcome, welcome, welcome in advance of Asteroid Day this coming Monday, June 30th. We are excited to have you on our live stream announcement for this year's Schweickart Prize winner. I'm Danica Remy, president of B612 Foundation and the home of the Schweickart Prize. I want to thank you for joining us. Now, before I hand things over to the members of the organizing committee and Rusty himself, I'd like to share a little bit about how this prize came to be. In today's briefing, Apollo astronaut and B612 and Asteroid Day co-founder Rusty Schweickart will talk about the purpose of the Schweickart Prize. And we'll allow time for questions at the end. Members of the press, again, identify yourself. With that, I'll begin with a little background on the next slide. Rusty has lived a life dedicated to the exploration and protection of our planet. A pivotal moment for him was his journey to space in the 1969 Apollo mission, which he'll speak about shortly. That experience shaped the path he's taken ever since, organizing international working groups to elevate global advocacy, co-founding B612 Foundation to build tools to help us understand, map, and navigate the solar system, as well as co-founding Asteroid Day, which after its founding was recognized by the United Nations as a global day of education and awareness. And just this last week was recognized by the United States Senate in honor of Asteroid Day's 10th anniversary. Rusty's lifelong commitment has inspired generations of scientists to work to protect Earth from asteroid impacts. In 2023, we launched the Schweickart Prize to carry that legacy forward, recognizing student proposals that advance our understanding of asteroids and to contribute meaningfully to planetary defense. Next slide. The Schweickart Prize is made possible thanks to the generous support of Anusha Ansari, the Barringer Crater Company, Future Ventures, Jeffrey Notkin, the Jurvetson Family Foundation, Meteor Crater, Randy Schweickart and Michelle Hang, and Rusty B. the Younger Schweickart, and Joanne Keyes, and the many supporters of B612 Foundation, including our founding circle, Asteroid Circle members, and individual donors from 46 countries around the world. Thanks to their support, this year's winner and future recipients will receive a $10,000 cash award and a museum-quality prize featuring an authenticated meteorite. Pictured in this photo on the right is Joe Martini, who is last year's and the first Schweickart Prize winner receiving his award and cash prize, and he's on the call with us today. Now over to Randy Schweickart, co-chair of the prize, for a few words on this year's process. Next slide.
Thanks, Danica. On behalf of myself and my co-chair and brother, Rusty Schweickart, I want to thank everyone who helped encourage students from around the world to apply for the Schweickart Prize. Our outreach ambassadors, many on the call today, and nomination committee members, some who are on the call today, are integral part of the Schweickart Prize organization and key to our success in finding prospective applicants. This year, we saw a rise in both the number and quality of applications with a diverse range of proposal topics submitted. This made selection of a winner for the 2025 prize especially challenging. We are extremely grateful for the insight and guidance of our nomination committee and friends in the planetary defense community in helping us assess the quality and potential impact of the various proposals. Owing to the strength and diversity of the proposals, we decided to award honorable mentions to two additional outstanding submissions. We'd now like to recognize these finalists and their proposal titles. Chloe Long, Anavid Pedrosfora, and Rahil Makadia for their proposal, Asteroid Impact Guidance and Information System. And Nitya Pendi for her proposal, YOSO, You Only Stack Once, for detecting unseen NEO threats. Both were creatively conceived, technically sound, and impressed the committee with their potential for advancing planetary defense in their respective fields. We invite you to visit the Schweickart Prize website to read more about these proposals and the talented individuals behind them. Congratulations to all three finalists. Now I'll turn over to my dad for his thoughts on planetary defense and the role of the Schweickart Prize. Next slide, please.
Thanks, Randy. For me, this iconic Apollo 8 image really marks a historic moment in the evolution of our life in our little corner of the universe. It's the image that signals what I have called our cosmic birth, the realization that Earth life is beginning and will continue to emerge into the larger universe, much as we all did at our individual births. A fascinating element of this is the seminal role that asteroids will play in this overall process. Not only will they serve as in situ resources to facilitate this future, but ironically, they pose as well an existential threat to this future in the form of destructive impacts. With this realization, we formed B612 Foundation, and the work we do directly addresses both sides of this great challenge, discovering and facilitating access to these great future resources and protecting Earth life from the occasional existential threat of an impact. Schweickart Prize recognizes the critical need for young, bright minds in addressing the many future challenges ahead in this regard. And in particular, this year's winners directly address the necessary environmental responsibility, that is, the cosmic environmental responsibility required to ensure that as we access future asteroidal resources, we do not inadvertently create additional long-term threats by redirecting asteroids toward future impacts. So with that, I'll turn it over to Rusty B to go more into the details here.
On behalf of the Schweickart Prize Selection Committee, congratulations to Jordan and his team members, Jim, Youssef, and Kosuke, for their prize-winning proposal, the panel on Asteroid Orbit Alteration, or PAOA. Today, to speak on behalf of the team, we have Jordan Stone, who is calling in from the UK. Jordan is a PhD candidate in the Department of Earth Science and Engineering at Imperial College London and will graduate in 2026. Considering the competition, this was a job well done. So over to you, Jordan, to tell us about the PAOA. Next slide.
Thank you very much, Rusty. So I'll talk about asteroid orbits first. So there are millions of asteroids in our solar system. A lot of them are found in the asteroid belt, but of course the ones that we care about planetary defense are the near-Earth asteroids. So there are about 15,000 near-Earth asteroids, larger than 140 meters in size, and about 1,000 asteroids larger than a kilometer. And so of those really large ones, the global community has detected now 87% of those, and that data is held at the IAU Minor Planet Center. And so that's obviously essential for predicting whether or not these asteroids are going to impact us in the future. And so this has been an amazing effort way before my career started. So yeah, and now it's sort of moving into a new phase where we are gaining the ability to alter asteroid orbits. So an interesting example that is not very well known is that NASA believed that they could do this back in 2013. They put in a proposal for an asteroid redirect robotic mission, which was to remove a boulder from a near-Earth asteroid and then put that boulder in orbit around the moon for research purposes. The mission ended up being cancelled in 2017 because of funding cuts, and instead we got the OSIRIS-REx mission, which went to a near-Earth asteroid and collected 122 grams of sample, showing that we can really go to an asteroid and bring samples back. So asteroid mining might be coming pretty soon. And then finally, the DART mission in 2022 showed that we can deflect an asteroid. So this was the first evidence that, we can really alter the orbits of asteroids. So that's an image of Dimorphos, the asteroid that was altered, taken from Earth. And so you can see the huge plume that was created when the probe hit the asteroid. And that significantly changed the orbit of the asteroid. That was a 160-meter wide one. So on the other side, we've got the research, and then the industry is starting to come up on the rise as well. And so, USA and Luxembourg have put in national policies in place allowing space mining companies to go and mine asteroids. They just need to apply for a permit to do that, and they can keep the resources or the profits from selling them. And so lots of asteroid mining companies are starting to pop up, like the Asteroid Mining Corporation, Starpath, and like Origin Space. But one that I think is quite interesting is Astroforge, to really get an idea of what the timelines might look like into the future. So they were founded in 2022, and since then, in 2024, they received $40 million in funds from venture capitalist firms. And then in 2025, they launched their first mission to prospect an asteroid to see if it was metallic. And they plan to send a follow-up mission called Vestry to go back to that asteroid and land on it, dock with it, and yeah, prove the space mining capabilities. Interestingly, this mission Odin, they actually lost communication with their probe, and so it's now lost in space. We don't know where it is, which is an interesting segue into things that could go wrong. So there are some plans to intentionally alter the orbits of asteroids in the future. There currently isn't a set proposal to do that, but I think it's something that might happen in the future as a first example. So yeah, if something goes wrong and you have a spacecraft malfunction or you lose communication with your spacecraft, then you could see how something could go terribly wrong if you're trying to move an asteroid into Earth's orbit or lunar orbit. But something that really caught my attention and I think motivated me to really look into this a lot further were the things that might be a lot more neglected. So, for example, we have accidental collisions with asteroids that might alter the orbits. So asteroids rotate really rapidly and they have irregular shapes, which means that approaching an asteroid and docking on it is actually quite difficult. And so we would expect that as the asteroid mining industry expands, then we might get like cases where spacecraft accidentally collide with asteroids. And so this is a proven capability to alter their orbits. Also, propulsion effects that we might not see coming, like if you mine an asteroid and kick your ejector out to space that you don't want, then that's a propulsion force. Landing on an asteroid and taking off from an asteroid are also going to impart propulsion forces. And we think you might be able to alter some of the forces, like the Yarkovsky effect, which is like from thermal radiation from the sun. But if you change the surfaces of an asteroid by putting structures on it, you can change that force as well. And so, yeah, there are lots of different propulsion forces, and they would be cumulative over time. And yeah, that might change the asteroid orbit in the long term. And then mass alterations as well, particularly relevant to asteroids in clusters, or if you've got an asteroid with a satellite orbiting around it, if you mine the asteroid that it's orbiting around, then you might gravitationally influence the other asteroids. And so most of these I see as being like cumulative effects over time. So a scenario I would imagine is like there's an asteroid with a 0.5% chance of hitting Earth in 2040. And because of these activities, maybe that percentage rises to like 10%, something like that. And this is something that we need to keep an eye on. So it's a problem for planetary defense because that data on asteroids would no longer be accurate if the orbits are changing. And that's the data that people use to predict impacts. So this is a problem. And at the moment, there's not really any research on mitigating this hazard. I've looked far and wide for it. And mostly you will find more proposals for how to mine asteroids. And where you would expect to find this is at the UN Working Group on the legal aspects of space resource activities. They have an initial draft of set of recommended principles for space resource activities, and it doesn't mention this potential hazard. So this is something this is a gap we want to plug. So we aim to do that with the panel on asteroid orbit alteration. So this would be, we aim to form an international panel to mitigate the hazards. So it would have 4 primary goals, and I'll go through each of those individually. Goal 1 is to conduct research into asteroid orbit alteration. So looking at these different scenarios, like accidental impact, like how might that occur? What might the impact be? So on the top right, maybe if you hit the asteroid at the top, you cause it to rotate and fragment into lots of pieces. Or just below that, maybe you create a propulsion force, like with the DART mission. So lots of modeling to do and maybe figure out some countermeasures or best practices to avoid this type of thing. And there's some existing expertise from the DART mission that could be integrated into doing this research, and also from looking at natural forces like the Yarkovsky effect. Goal 2 is to create guidelines to mitigate those risks based on that research. So guidelines are quite trendy now in the space sector, especially space policy. So one example, the one in the middle, is the COSPAR policy on planetary protection. So this is a set of guidelines on how to avoid contaminating other planetary bodies so that you don't like ruin scientific investigations. And so these guidelines are non-binding. So that's particularly useful if you're trying to put in place guidelines for countries that don't necessarily want to be told what to do. They are updatable. So as new technologies emerge for asteroid mining, the guidelines will be able to be updated to like meet that. And they're easier to implement than, say, an international treaty where you need to get lots of agreement and lots of word altering. So yeah, you get international experts together to figure out what the best practices should be, and you produce those guidelines. So they might include things like send a risk assessment to the PAOA on what you plan to do, and what's your response plan if things do go wrong, and who's liable for like mitigating those risks. Those are currently like total uncertainties. Goal 3 is to collect and share essential information and data. So the PAOA would work closely with space agencies and the commercial sector, and they would ask questions like, what asteroid do you want to go and mine? And like, is it possible that you will alter the orbit of that asteroid? And then it would also have a foot in the door of planetary defense too. So you would say to the IAWN, this asteroid mining company has interacted with this asteroid. Can we get an observational follow-up on its current orbit? So the International Asteroid Warning Network is a global network of observatories around the world who like detect asteroids and define their parameters. And so you can get follow-ups on an asteroid that might have been altered. And then that can get updated on the official datasets. And then that can go to the organizations like CNEOS and NEOCC who can like predict the impacts. So there's like a feedback loop there that I think is like an essential node that the PAOA fills for mitigating this risk. And then you would have observers as well, like Committee on Space Research, who would be interested in this. And goal 4 is to produce policy recommendations. So I can envision the PAOA interacting with the SMPAG quite a lot. The SMPAG is the Space Mission Planning and Advisory Group, and they are basically lots of space agencies working together to figure out how you would respond to a potential impact to Earth. So how you would send a deflection mission, for example. And then also talking to national and international authorities. I can see the national licensing schemes being really important here. Like you can say, okay, we'll give you a permit. If you're the US government, you can say, I'll give you a permit to mine an asteroid as long as you follow those guidelines that the PAOA created. So you'd want to talk to like these authorities too. So our next steps are to engage with the Committee on the Peaceful Uses of Outer Space. So really handily, there is a past precedent for this. So Rusty Schweickart on the call was the chair of a team that produced a report recommending the creation of the SMPAG and IAWN, which are now at the heart of global cooperation for planetary defense. And so we'd want to follow that path as well. So that would be forming an international action team to produce a report to like outline the risks and what needs to be done, and then presenting that to that working group I mentioned earlier on the legal aspects of space resource activities to eventually create the PAOA. And we'd like to run some SGAC. The Space Generation Advisory Council has project groups, so we can do some research to like feed into that as well. And obviously we'd like to talk to member states too, who would be presumably advocating for the proposal at UN COPUOS, if we're lucky. And so to summarize, asteroid orbits will be altered by upcoming space activities. This reality will complicate planetary defense initiatives, and the PAOA will investigate the risks, provide oversight, and share crucial data. And I see this as like totally essential to like long-term security against asteroid impacts. And we want to go through the Committee on the Peaceful Uses of Outer Space to create the panel on asteroid orbit alteration. And that's my contact email there. Please feel free to email me if you have any questions. We'll have a Q&A after this as well. But also, if you'd like to if you're a young person and you want to get involved in a research project to investigate these risks, then yeah, especially please get involved. Thank you. I think I'm passing back to you, Danica.
Yep. Thank you, Jordan, and to the rest of the team who worked on this winning proposal, and Rusty for your work and dedication to advance planetary defense. And thank you to the Schweickart Prize team who are on the call today, which includes Randy and Rusty, the younger, fondly referred to as the twins, Delphine, who is our Schweickart Prize manager, and Colleen, our director of special projects, which basically means she makes everything work. Without this team and the support of donors around the world, B612 and the Schweickart Prize would not be possible. Having operated for over 2 decades, B612 is the only NGO in the world dedicated to protecting the planet from asteroid impacts. We're grateful to those on the call and those who support our vital work for the future of our home planet. And next, we have a special shout out for one of B612's strategic advisors and fellow Asteroid Day co-founder, Dr. Brian May. Brian has been a co-conspirator with us for more than a decade and a leader in advancing public awareness about planetary defense. Next slide.
Hi folks, it's Brian again. Just a quick shout out from me to the one and only Rusty Schweickart. We all owe him so much for his leadership in this worldwide campaign to raise awareness of the importance of asteroid surveillance as a step towards protecting the future of our planet. Big shout out also of appreciation to the Imperial College team and all who have so massively raised our game in near-Earth asteroid detection. Thank you, Rusty. We salute you.
And thank you, Brian, for sharing that with us. Now we're going to move into our favorite part of our program, which is always the questions from our community. I don't see any questions from our colleagues in the press. If you want to submit some questions now, that's great. Delphine put in the chat the link to the final proposal. There was a little bit of a hiccup with our press release, so this is the final proposal. And with that, I guess I'll start with a question from Alec, which says, seems like we need some form of a database of the maximum possible momentum change to a given, oh, this is a very technical one, given a spacecraft that could impact on asteroids it's interacting with. Which body would be responsible for maintaining that complete list?
Yeah, I guess I can answer that question. So at the moment, the IAU Minor Planet Center holds all that data on what the asteroid orbits are. And so what I understand is that you're proposing a second data set on what the orbit alteration thresholds would be for the maximum orbit alteration for each asteroid. And so, yeah, I would see that being part of the panel on asteroid orbit alteration to maybe even define maximum orbit alterations per potentially hazardous asteroid. So yeah, that may be part of the guidelines that might be linked there. Yeah.
Great. Patrick, Michelle, your question?
Yes, my question.
Thank you for your work on helping us find Schweickart Prize winners, by the way, part of the nomination committee.
And I said, honoring Rusty is very important. So whatever I can do to help. Yeah, so it's very good. Actually, it's a suggestion. So it turned out that I'm in the steering committee of the International Asteroid Warning Network and also a delegate in the SM page. And I was thinking that maybe you should probably present this to the SM page because there is, I think, a connection with the legal working group. You're going to define criteria. But if you define criteria and the space agencies don't follow them, it's useless. So I think having being within the SM page and defining with them what makes sense or not could make sense. So I'm just offering that if you want to present that to SM page, I can try to see how we can fit it in the program.
Oh, amazing. Yeah, definitely. Sounds like a really cool idea.
Patrick, thanks for that. And I think Jordan didn't mention the potential membership of PAOA, but I think there would be representatives from Same Page and IAWN and other key bodies, existing bodies on the panel. So that's excellent idea, and I happily I think it's already underway, or at least in thought form.
Good.
One of what we hope is the benefits of highlighting these kinds of proposals is opening up the network that B612 and Rusty and our network of nomination committees and ambassadors have. And so while there is a cash prize and a beautiful award and the sort of public recognition of the idea, really the idea with this is to help open up doors for a new idea. So exactly what you just mentioned here, Patrick, is really the goal of what we have created with this Schweickart Prize.
Yeah, great. I will just add that I have another idea is that since we talk about protection, at COSPAR, there is a planetary protection group which takes care of, all the biological problems if we return samples from Mars or when we bring something to planet. But there could also be a group dedicated also to this. So we just have to understand where is the best place to put it in relation with same page and COSPAR because
Mhm.
there are different ways.
Yeah,
But the best,
definitely.
I would say, sorry, the best is also to present your work in also at COSPAR. There is a General Assembly next year, 2026. It's in 1 year, but we takes time. And as I said, same page, and that way you will have feedbacks and gives better idea what's the best scheme.
Yeah. And in part, again, any doors that you can help open for us, Patrick. We have another question that's come through. Can you, Jordan and team, sort of foresee how you're going to involve the private sector? Presumably, asteroid mining orgs and others will want their own research on orbital alterations for communications and return missions.
Yeah, sure. So one of the first steps is to create an international action team, right? To look into these threats and come up with like what the possible scenarios, what could go wrong, how do we mitigate it? And so that action team would have to be like really closely linked to industry and having that input right from the beginning. Because yeah, I don't see this being something that's against asteroid mining at all. It's like a problem we've identified and we need to solve it, and solving it helps asteroid mining like progress. So yeah, definitely having asteroid mining or commercial industry like involved right from the beginning in that action team seems like really important to me. There is a question about like impartiality in that action team, which I think we'll have to address at the time. Mainly, I think we want to keep the action team to like experts in the field. So yeah, that might come from industry, that might come from academia, that might come from whatever. But yeah, I think space agencies and industry need to be like totally involved right from the beginning to like figure out exactly what the guidelines and recommendations need to say.
Great, thank you. It might be useful if there's any questions that come forward for some of the other members who are on the call today on the winning team to see if they can also answer some of these questions if they're relevant. Imagard?
Yes, thank you very much, and congratulations to the winners of the prize this year. And it's a particular pleasure that it comes from a policy perspective. I'm an international law professor and talking about space law all the times and space law and policy. And I'm also part of the SamePage legal working group and part of the SamePage Austrian delegation to SamePage. I think what the graph you show in your the chart is very intriguing and very well thought through. One question arises to me because it came to my mind that how important it is when I see this, how important it is to network, to be part of the network, to know the people who are doing things in that area. And for me, this has been over the years very helpful to better understand the dynamics, who is doing what, and how is interaction working. The question now is the Planetary Defense Conference is another tool of networking. Have you had some thoughts about presenting your work at the next Planetary Defense Conference? They are biannually organized. Once we had them in Vienna. And so that would be a question or suggestion to increase the network or the your network, and also then increase in the awareness of your project to the Planetary Defense Conference community. That would be my question.
Yeah, absolutely. So I think we just missed the last Planetary Defense Conference. I think it was last month. I've talked to Alex Carl, who organizes that, about this proposal already. And we plan to present at the next one in 2 years. And they might organize a smaller version of the Planetary Defense Conference in a year's time. And I've talked to him about potentially having a workshop there to bring like all the experts together to talk about this and come up with solutions. So absolutely, yeah, definitely.
Great. Yeah, I would, Joe, if you wouldn't mind unmuting for a moment. That is one of our hopes. And Joe DiMartini, who is last year's winner, in fact, did present at this year's Planetary Defense Conference. Do you want to just say a little bit about what winning the prize has meant for both your work and for your network?
Yeah, absolutely. I mean, for one thing, just the chance to get to show off my proposal from last year was an outstanding opportunity. I had a lot of people congratulating me and reaching out for collaborations and those sorts of things. So the Schweickart Prize really is a huge deal in terms of expanding the network for up and coming researchers like me or like this year's winners. The Planetary Defense Conference itself is this great congregation of people from all walks of planetary defense, from the disaster response to the policy to observations to modeling and everything in between. And I think what you guys have here is a great cross section of that as well. Congratulations to you all. This is a really excellent proposal. Just been skimming it as we've been going through the questions, and it's amazing.
Great, thank
Thank you
you.
very much, Joe.
I do have a question from Gina at CBS. Her question is, how has technology changed to make asteroid missions more possible? And I'm not sure who wants to respond to that. Probably Rusty to start, and then we can go around the room with some other expertise on that.
Well, I think that the biggest change has been the lowering of costs to launch to get to orbit. That's a huge has a huge effect on what can be done in terms of getting to asteroids and what can be done in terms of both exploitation of asteroids and defense against potential threats. In addition, of course, the detection systems, witness the new image that just came out the other day from the Rubin telescope. I mean, tremendous acceleration in our ability to discover asteroids, and completing the inventory of asteroids is going to be very critical to moving ahead on both sides, both exploitation for future space development and migration and that kind of thing, but also in terms of protection of life here on Earth. Those are the two immediate things that come to my mind. I do want to say that what is really contained in this proposal by Jordan and his team is, in essence, an environmental impact statement for continued development of resources in space. And like any environmental impact issue, it's going to be controversial. And one of the reasons why we moved ahead with this proposal of Jordan's is that if you're going to have an environmental impact component to anything that you do, you better start it early. You don't want to come in late when there are tremendous vested interests at work. It's better to involve them in the beginning so that not only the protection of the environment, but also the development of the commercial application, whatever it may be, can move ahead smoothly and does not have unnecessary hiccups. So this is a very timely proposal that Jordan and his team came in with, and we were delighted to handle it.
That's great. That's great. I'm going to call on my colleague, Dr. Ed Liu, actually to say a couple of things about how the asteroid missions are becoming more possible and the emerging asteroid mining market that we've been talking to here at B612 for some of the tools we've been building.
Well, just like Rusty mentioned, the tremendous decrease that we're seeing and in launch costs and the tremendous rise in number of missions being flown, satellites being launched, is a sign that things are changing. And I think that over the next few decades, a lot of things that people had thought like, oh, those things are so off in the future are actually going to become real issues. And so, this idea of us, living, working, carrying out operations throughout the solar system is, I think, actually sooner than many people believe. So I'm looking forward to seeing a lot of these things happening. And as is pointed out here, this does have a relevance to planetary defense.
Great. Thanks very much. I see Patrick's got his question up, and I'm just wondering whether or not before we go to your question, Patrick, and I see yours as well, Joel. I'm wondering, Brian, if you might feel comfortable saying a few words, or if you have any questions. I see you jotting things down there, my friend. So.
Yes, you're spying on me, I see.
I'm sorry.
Yeah, this stuff is important. I think, I was quite surprised actually. I'm joking about it, but this is important stuff. And if we can't persuade astronomers to get into it, how can we persuade the general public? Anyway, can I say big congratulations to Jordan and his team. I caught most of your presentation. It's great. What a wonderful contribution that is, and very far-seeing and very beautifully explained, if I may say so. Congratulations.
Thank you. Thank you very much. I really appreciate that.
Great. Thank you. Thank you, Brian. And one of the things about advancing the Asteroid Day program activities, we're really excited that Senator Mark Kelly and John Calhoun introduced a bill to the U.S. Senate floor yesterday to recognize Asteroid Day domestically here in the United States, and where we're going to be presenting officially the prize to Jordan in Flagstaff. The city of Flagstaff and the Coconino County also has recognized Asteroid Day. So those are the first 3 places after the United Nations to recognize Asteroid Day. And that's why we also choose to present the prize on Asteroid Day. It's an important focal point for people to start talking and thinking about asteroids. And I'm grateful to Rusty and Brian and Greg, who's not here on the call, for having the willingness to step up and say we need to educate the world. And so thank you, Brian and Rusty and Patrick and Michelle, who's moved a lot of things along, as well as Doran, who took the resolution to the United Nations in 2016, and the important work of the Association of Space Explorers.
Can I butt in and say thank you? Thank you on behalf of us all to you, Danica, for your absolutely tireless energy that you put into this, and you keep bringing us all together. I mean, I keep slipping away somewhere, and you keep reminding me where I ought to be. So thank you from us all.
Thank you, Brian. So I'm going to go to Patrick, and then I'm going to go to Doran.
Yeah.
Okay, Patrick, because I'm the bus heading to the airport.
Oh, okay.
Okay.
So I don't know how long I can keep the selection, because I'm the bus heading to Luxembourg to take part in the Asteroid Day celebration. And first, I wanted to congratulate Jordan. Yeah, it's a really very interesting and important work he did together with his team. And I want also to congratulate all of you, Rusty, Randy, Rusty number 2, Brian, because we met in Bucharest 2 times, Danica, and all the stuff. Congratulations, and keep going on. Thank you.
Thanks, Doran.
Thanks, Doran.
Patrick?
Thanks, Doran. Hello, Brian. Happy to see you. Thank you for this Asteroid Day. 10 years, it's crazy. I wanted to answer. Oh, it's great. I mean, this is great because we inspire the young generation. We do, we have space adventures. When we talk about space missions to asteroids, Indiana Jones can go to sleep because we do much better than him. And in fact, to answer the CBS journalist, I think I would like to say 2 things. One technology which really improved and is really important is autonomous navigation, because DART could impact on Dimorphos thanks to a smart navigation system, and we do also natural feature tracking when you do close proximity operation around an asteroid. So I would say the past space missions really teach us a lot about how to perform close proximity operation around very low gravity body. And by the way, Brian, the reason why the cosmologists don't understand the value is because they don't understand that low gravity is as interesting as super high gravity and black holes. We are in very 2 extremes. And I would say that what we also learned thanks to the mission that interacted with asteroids like OSIRIS-REx, Hayabusa 2, DART, is that the behavior is sometimes and most often counterintuitive. They are in a so different environment than Earth that sometimes we think based on images that the surface is going to be hard, And when we touch, it has no cohesion, no strength, which is really crazy. And so I think all these missions allowed us not only to reduce the cost because we know better, so we reduce the risk, but also to realize the very wide diversity of these bodies and their complex geology, which means that we still need to learn how to interact with them to make sure that at some point we have a robust plan to deflect them. So we are still in the learning stage, and it's fascinating for the young generation. Asteroid Day is really the great moment to share that with the public, that we are doing adventures which are full of surprises, and we show to the world that despite these surprises, when we work together with passion, efforts, etc., we solve crazy problems which seems impossible to solve, and we tackle challenges in a way that I hope can show to the world and the rest a good example so that we can tackle the challenges we have on Earth.
Thank you, Patrick. Thank you for being so eloquent. And you are the face on the science side for much of the asteroid science, and we are grateful for your enthusiasm and earliest supporter of this crazy idea we came up with. Okay, so with that, Joel, thank you for being so patient. I wanted to make sure that we had an opportunity for all of our experts to say something or ask questions. What is your question, my friend?
Well, first, like everybody says, congratulations to Jordan. And it was very insightful of you to see that there can be problems that arise inadvertently. In fact, I think the original deflection dilemma proposed by Sagan and others was that some malign power might redirect an asteroid into the Earth. Of course, Rusty Schweickart came up with the real deflection dilemma because the malign power scenario is not very realistic. But yours is certainly realistic, to see that the danger could be caused inadvertently. But regarding that, it struck me that you were emphasizing prevention, which of course is the paramount concern. But I would think inevitably something will go wrong. And so I would just suggest, if you haven't thought of this already, that be part of the proposal. I mean, in terms of like liability and things like that, when inadvertently something happens, we have to be prepared to deal with that, no matter how many precautionary guidelines there are, even if people are conscientiously trying to abide by the guidelines.
Yeah, definitely. I don't know if Rusty, you want to comment on that first? Okay, yeah, so we have thought about the liability stuff in the proposal. So we've actually looked at oil mining as a potential like analog. So they have something called the International Oil Pollution Compensation Funds, and that is like every member or every nation that receives oil from oil mining companies pays into a collective fund. And if there's an oil mining disaster, then the funds from those nations go to paying for mitigating like the hazard that might be posed by that oil mining disaster, like cleaning up the oil, that sort of thing. So I can envision something similar to that, where like any country that receives space resources pays into this fund, and then those funds get to fund like an asteroid deflection mission. So yeah, definitely.
Oh, and another group that would certainly be interested in hearing you would probably be the Small Bodies Assessment Group at NASA, which just had a meeting, by the way, and they do welcome young researchers. Unfortunately, because of all the budgetary problems occurring with NASA now, it's not certain that that group is going to continue to exist, which would be a tragedy if it didn't. But I would encourage you to look into that.
Right.
Awesome. Will do.
Well, I just will give it one more minute to see if there's anybody else who's got a question or a congratulations. If so, raise your hand or Okay, Brian.
This is a little off piece maybe, but and it's not the first time this has been mentioned, but we live in a fairly orderly solar system and we kind of know the rules, and we're learning what the full population is. What are the current thoughts? Does anybody have any thoughts about extra solar system visitors? as we move through the interstellar medium? Do we have any knowledge of what the risks might be that something like Oumuamua can come and hit us instead of something from inside the solar system?
Who wants to try and take that question of my colleagues? I'll go to Ed and then Patrick.
I can say that the fraction of objects in the solar system that are extrasolar is really, really, really small. And so, you know, from a collision standpoint, certainly they're just the numbers are way down. The speeds are high though, you know, not that different than comets. So maybe, you know, but even still, I think most of them are quite a bit less common than even comets. So I think maybe more of a scientific interest at the moment.
Patrick?
Yes, in fact, when we discovered Oumuamua, we thought there would be about one interstellar object coming in the solar system per year by debiasing the observations. Then we got Borisov, I guess, a year later, so it was going well. So, but then we don't. They are difficult to observe. They are very infrequent, even if they are just one per year. Their trajectory being highly inclined compared to the Earth's orbit make it very improbable that, because they have not only to cross the orbit of the Earth, they also have to cross the orbit of the Earth when the Earth is there. So I would say the same issue with the long period comet. They also have the same kind of orbits, highly inclined, etc. So if we start to worry about interstellar objects, we should also worry with long period comets. But again, it's a question of accepting risk. We cannot have zero risk, but compared to all other objects that pose a risk and for which we can do something, this is one we have to live with. With, of course, the problem that since they are highly inclined, they come at high speed. But I agree with Ed, it's more a scientific interest because it's super cool to understand where they come from. And with Oumuamua, we have a story we still don't understand. But yeah, for the risk, I would say compared to the other ones, they are really on the very, very low end. So.
And Brian,
Thanks, Patrick. Ed, can you maybe say a little bit about sad we don't have any of our University of Washington friends on the call, but talk a little bit about Vera Rubin's.
Yeah, I was just going to mention that Rubin, if does expect to perhaps be able to find some of these over the upcoming years, because it's more sensitive than anything else at looking for such things. So I think we do stand a decent chance of finding some of these. Again, we don't know how many of them there really are, but probably look more than likely we'll see some.
The other problem, Brian, is ultimately assigning responsibility and accountability. I think that's going to be pretty tough. You know, they're going to be they're not intentional, and so there's not much we can do in terms of accountability. Not until we get to meet the aliens, anyway.
Yeah.
Okay.
Yeah. Thanks.
Great. Well, I think with that, I want to once again thank all of you for joining us. I want to congratulate the team, Jordan, Youssef, Kusi, and Jim, who's not on the call with us. We will be continuing to celebrate their work and trying to amplify information about what they have proposed to see that this idea gets some legs out in the real world. And that's really the intention of the awarding of the Schweickart Prize, is a novel new idea from the next generation who are going to help us think about how to protect our planet from asteroid impact. So with that, I really want to say thank you to everybody on the call. From all of us at B612 and the Schweickart Prize, we are wishing all of you a very happy Asteroid Day, June 30th. Mark your calendar. Always have a party on Asteroid Day if you can. And we're grateful for your support and interest. And again, congratulations to the team.
Thank you. Thank you very much.
Thank you, Danica.
Thank you very much,
everyone, for
Danica.
joining.
Thank you very much.
Congratulations, Jordan and team.
Thanks, Randy. Cheers, everyone.
Thank you.
Congratulations.